All right, hello and welcome. So today we are talking about complex numbers. And before we get into what that means, let's just kind of do a quick recap of exponents and square roots. So um, just looking at what I've written down, we know that anytime you see an exponent, it means multiply a number to itself that many times. So if I want to find the value of 3 squared, we know that that's the same as 3 times 3, which we know comes out to 9. So when I see a square root, right, that's just the inverse of having an exponent. So the square root of 9 is 3 because 3 times 3 equals 9, right? So let's keep that in mind. Under that, I see negative 3 squared. So I know that when I do negative 3 squared, right, negative 3 times negative 3 still comes to a positive 9. So if I follow the logic from the problem above it, when I try to take the square root of negative 9, I run into a problem. Because when I squared that negative 3, it switched into a positive. So if I try to write down a negative 3 right here, I know that's not correct. So way back in the 1500s, when they kind of ran into this issue for the first time, there were some Greek mathematicians that decided that instead of putting a negative on that 3, we're going to use the letter I to indicate that this negative square root technically doesn't work, but for the purposes of solving the problem, we will pretend that we have this imaginary number. So when you see that I, right, the square root of negative 1, we just write down the letter I. So by the logic that we've seen in the first two examples we worked, that tells me that I squared has to equal to negative 1. So let's see how this works with a couple more examples. So anytime we need to take the square root of a negative number, we're going to imagine that that number was positive. So we'll change the negative and put the I in front. And then from there, you just simplify as much as possible. So if I know that square root of 25 equals to 5, then my final answer for this one would be 5i. For the negative 36, we would do the same thing, right? So I imagine that it's positive, and then when I square root the 36, it becomes a 6, so my answer is 6i, or an imaginary 6. If I run into a number like negative 48 that does not have a whole number square root, then I can still simplify it. I just need to think of numbers that multiply to make 48 that do have square roots, and that will tell me how to reduce this. So we're always going to start by changing that negative into an imaginary positive. Then we're going to look at numbers that multiply to make whatever numbers under the square root. So in this case, I know it could be 1 and 48, but 48 doesn't have a square root, so it doesn't help me. I know it could also be 2 and 24. And then I know it could be 3 and 16. And as soon as I hit that one, I'm going to stop, because I know that 16 actually does have a whole number square root. So I want the 3 and the 16. And then I'm going to take the square root of both of those numbers. The 3 does not have a whole number square root, but the 16 does, and so that reduces to a 4. So when I'm writing down my final answer, I need to copy down the imaginary I. I need to copy down the 4 from the simplified 16, and then since the 3 didn't have a square root, I will just leave it under the radical sign. So the square root of negative 48 simplifies to 4i square root 3. For the negative 300, we'll do the same thing. Right, we're going to have an imaginary I. I know that 1 in 300 will multiply to 300. I can do 2 in 150, which doesn't help me a whole lot. But if I do 3 times 100, that will. So just like last time, the 3 does not simplify, but the square root of 100 equals 10. So I need the imaginary I, the 10, and the square root 3. Another thing that we're going to see is combining two complex numbers. So complex numbers are numbers that combine both a real number, so a regular value like the 2 or the 6, with an imaginary number like the 3i and the negative 8i. The thing about this is it's the same as if those i's were x's. So we're basically just looking to combine like terms like we've seen in previous videos. So if I was doing this, I notice there's a plus sign between the parentheses, so it just wants me to add the two groups together. So I will do 2 plus 6 to get 8. I will combine my i's, so 3 plus negative 8, or 3 minus 8 will give me negative 5i. So the simplified version is the complex number 8 minus 5i. For multiplying, it's going to be the same idea. It's going to work just as if those i's were x's. The only thing that's different is that I is special, right? We know from earlier that I squared equals to negative 1. So I'm going to need to keep that in mind as I am finalizing my answer. So I will start it off just like before, where I do 2 plus 3i times 6 minus 8i. And then we'll distribute just like we did when we were multiplying our polynomials. So 2 times 6 will give me 12. 2 times negative 8 will give me negative 16 with the I. 3i times 6 will give me 18i. And then 3i times negative 8i will give me a negative 24i squared. And so here's where the extra little bit comes in. So we said that I squared is negative 1. So if I see an I squared, I'm going to change it into a negative 1. And I know that when I multiply negative 24 and negative 1 together, all it's going to do is switch that into a positive 24. So when I go to combine my like terms or to simplify the inside of my box, right, the 12 and the 24 are now like terms. So 12 plus 24 would give me a 36. And then when I go to combine my i's, I have 18 minus 16 So that would give me a positive 2i. And since I've combined everything inside the box, the complex number 36 plus 2i is my final result. And that's all I have for this one. I will see you guys next time.